Hi, right now we're gonna be discussing about linear differential equation. And in linear differential equation, first that we must consider is to know if it is linear in x or y. So whenever an equation is linear in y, we'll be using this formula: y times e to the power of p of x dx is equals to q of x e to the power of p of x dx. So whenever an equation is linear in x, we'll be using this formula, which is the x times e integral to the power of the integral of py dy is equal to q of y e to the power of py dy. So now for our sample equation for linear differential equation, so we have y prime is equal to cosecant of x plus y cotangent of x. So first, we must make it dy over dx since it's in y prime, so it should be equal to cosecant of x plus y cotangent of x. Since we have to make it in linear form, we're gonna have to transfer this to the other side and change the sign, and it will become negative. So we have dy over dx minus y cotangent of x is equal to cosecant of x. So it's already in linear form, and as what you can observe, in it's linear in y. So we're gonna use the formula y e to the power of the integral of p of x dx is equal to q of x multiplied by e to the integral of p of x dx and dx here. So now we're gonna substitute the variables. So we have y e to the power of the integral of rpx is cotangent of x. So this will become, since it's in negative, this would be negative cotangent of x dx is equal to, and our q of x is this term here, we have cosecant of x. So should be cosecant of, sorry, it should be cosecant of x. Then we must integrate, sorry, it must be an integral. So multiplied by e to the integral of, this would be negative cotangent of x dx and then dx here. So and now we're gonna simplify this term. So we have y e, for the integral of negative cotangent, we have negative ln of uh, negative ln of sine x, and then equal to the integral of cosecant x multiplied by e to the integral. Our integral for negative cotangent is same as here. We have negative ln of uh, sine of x dx. So um, we know that there is a negative one here, so we can make it as our exponent. So this would become y e to the ln of sine x, then to the power of our negative 1 here, and make it as an exponent. So this will be equal to the integral of cosecant of x multiplied by e same as what we did here. So we have ln of sine x to the power of -1 and then dx. So we know that e to the power of ln could be cancelled, so we have to cancel this ln. So we're left with y multiplied by sine x to the power of -1 is equal to the integral of this would be cosecant of x multiplied by sine of x to the power of -1 dx. So right now uh, we have to change this its identity, since um, we knew sine x to the power of -1 is equal to 1 over sine x, and then equal to uh, the integral of cosecant of x multiplied by 1 over sine x, then this could be dx. Since we know that 1 over sine x is the identity of cosecant, so right here we're gonna have to change it into cosecant. So we have y of cosecant of x is equal to, we have the integral of cosecant of x multiplied by cosecant of x dx. So we're gonna combine this since they are in the same term. So we have y cosecant of x is equal to the integral of cosecant squared of x dx. So now we're gonna integrate this integration. So we have um, y cosecant of x is equal to, we knew that cosecant squared x is equal is an integral of negative cotangent of x plus c. So uh, in order to get the y, we're gonna have to uh, divide both sides by 1 over cosecant of x. So this will be 1 over cosecant of x. This will be y is equal to negative cotangent of x over cosecant of x plus c. So as for the identity of cotangent, we have cosine of x over sine of x, and then for the identity of cosecant, we have uh, should be divided to we have 1 over sine, so 1 over sine x, sorry, and we can cancel that out, and it would gonna be equal to cosecant of x. So for our y, we have, this should be equal to, sorry, I forget for the c, it should be also divided to cosecant of x. So now since this is constant, our constant is in the numerator, so we can just copy that. We have c over cosecant of x. So since this would gonna cancel that, we we're gonna have to subtract. So since we're left with cosine of x here, so this would be minus cosine of x. Then next thing is we knew that there is an imaginary one here, so we can factor that out. So this will become 1 over cosecant of x times c, or the constant, minus cosecant of cosine of x. So this identity is, we knew that 1 over cosecant of x is the identity of sine x. So this would become uh, sine x, or times or multiplied by c minus cosine of x, or simply we could uh, multiply this term, so this would become c sine of x, sorry, this would become sine of x minus cosine of x. So this would be our result for solving a linear differential equation. Now for our second example in linear differential equation, we have the quantity of y minus cosine squared x dx plus cosine of x dy is equal to 0. In order to get the dy dx term, we're gonna divide both sides, or divide each term by 1 over dx. So this is gonna cancel the dx there, so we only left with y minus cosine squared of x plus cosine of x dy over dx is equal to 0. So we're gonna transfer this term here and use it as our q sub x in later. So this will become we're gonna put it first since we have the dy dx here. So this will become cosine of x dy over dx plus y is equal to, this will become positive cosine of x, cosine squared of x. So in order to eliminate this cosine of x, we're gonna have to multiply both sides by 1 over cosine of x. So this is gonna cancel that. This will become dy over dx, and then we have what plus y over cosine of x is equal to cosine squared of x over cosine of x. So in linear form, dy here must be multiplied by the p of x. So this, we must make it dy over dx plus this will become 1 over cosine of x multiplied by y is equal to since they're the same term, and then we're just gonna have to cancel that, so we're left with cosine of x. So as what you can observe, it is already um, in the um, in what you call by that, it is already in uh, linear form. So since it is in fraction, so and also an identity of a secant x or a secant, so we're just gonna change it to secant. So this will be dy over dx plus secant of x, secant of x multiplied by y, or secant of x y is equal to cosine of x. So now it's already in linear form. So we're gonna, since we can see that it's in linear in y, so we're gonna use y e to the integral to the power of the integral of p of x dx is equal to q of x, or the integral of q of x times e to the integral of p of x dx and dx here. So now we're gonna substitute uh for its standard form for linear equation. So we have y then multiplied by e to the integral of rp of x is secant of x. So this would be secant of x. uh, I hope you can see that secant of x dx is equal to, we have rq of x is cosine of x, so we have the integral of cosine of x multiplied by e, and then this would be to the power of the integral of secant of x dx. So now we're gonna integrate the exponents. So we have y e to the power of the integration for secant of x is secant of x plus tangent of x. So we're gonna put we have ln of, sorry, the integral for this is ln of secant of x plus tangent of x. So this would be ln of secant of x plus tangent of x, then equal to the integral of cosine of x multiplied by e. Same as here, we have uh, ln of secant of x plus tangent of x. So also we can cancel this ln here, so gonna cancel that. So this would, we're left with y multiplied by secant of x plus tangent of x is equal to the integral of cosine of x multiplied by secant of x plus tangent of x. So also we have a dx here. Sorry, I forgot to put that. This would be, we have dx here also, so this would be tangent of x dx. So right now we're gonna distribute this cosine of x here. So this would be y secant of x plus tangent of x is equal to we have the integral of cosine of x secant of x, then plus cosine of x and tangent of x, and then don't forget the dx. So we have y secant of x plus sorry, this would be tangent of x is equal to we know that secant of x is an it has, it could be uh, it has an identity of 1 over cosine of x. So 1 this should be cosine of x then multiplied by 1 over cosine of x, since it is the identity of secant of x, so this is gonna cancel that out, so we're left with the integral of only the dx. Then plus, uh, we have the cosine of x, and then multiplied by tangent of x, since we know that tangent of x is equal to sine of x over cosine of x. So also that we're gonna cancel the cosine, so we're left with sine, so this would be dx plus the integral of sine of x dx. So now we're gonna integrate for its value. So we have y secant of x plus tangent of x is equal to the integral of dx is only x plus the integral of sine of x dx is negative uh, cosine of x plus c, or we can make it y times secant of x plus tangent of x is equal to x is equal to x plus minus cosine of x plus c. So this will be our general or final answer. Tama.